The capacity of an atom of an element to form chemical bonds is known as its valency. The valency of an element decides the number of other atoms which can combine with one atom of the element. The valency of an element is decided by the number of valence electrons in the atom. Relation between valency and valence electrons. Only valence electrons take part in chemical combination. So, the valency of an element depends on the number of valence electrons present in the atom. The valency of an element is either equal to the number of valence electrons in its atom or equal to the number of electrons required to complete 8 electrons in the valence shell. Usually, metals have 1, 2 or 3 electrons in the valence shell. They lose these valence electrons during chemical combination. So, the valency of metals is equal to the number of valence electrons. But in the case of non-metals, the valence shell contains 5, 6 or 7 electrons. Hence, they accept 3, 2 or 1 electron to complete the octet. So, the valency of non-metals is equal to 8 minus the valence electrons in the atom. Valency of metal equal to number of valence electrons in its atom. Valency of non-metal equal to 8 minus number of valence electrons in its atom. Types of valency. There are 2 types of valencies. If an element combines with another atom by losing or gaining electrons to form electrovalent bond, then the valency is known as electrovalency. If an element combines with another by the sharing of electrons to form covalent bond, then the valency is known as covalency. Electrovalency. Elements which form electrovalent compounds show electrovalency. The number of electrons lost or gained by one atom of an element to achieve the nearest inert gas configuration is known as electrovalency. The elements which lose electrons form positive ions and have positive electrovalency. The elements which gain electrons form negative ions and have negative electrovalency. Examples of electrovalency. Valency of sodium. The atomic number of sodium is 11. The electronic configuration is 2, 8, 1. Sodium atom loses the valence electron to form sodium ion, Na positive. So, the valency of sodium is 1 or 1 positive. Valency of magnesium. The atomic number of magnesium is 12. The electronic configuration is 2, 8, 2. Magnesium atom loses the valence electrons to form magnesium ion, Mg2+. So, the valency of magnesium is 2 or 2 positive. Valency of chlorine. The atomic number of chlorine is 17. The electronic configuration is 2, 8, 7. Chlorine atom accepts 1 electron to form chloride ion, Cl negative. So, the valency of chlorine is 1 or 1 negative. Valency of oxygen. The atomic number of oxygen is 8. The electronic configuration is 2, 6. Oxygen atom accepts 2 electrons to form oxide ion, O2 negative. So, the valency of oxygen is 2 or 2 negative. covalency. The number of electrons shared by one atom of an element to achieve the nearest inert gas configuration during the formation of a covalent compound is known as its covalency. If an atom shares one electron, then the covalency will be 1, and if it shares 2 electrons, then the covalency will be 2. Examples of covalency. Covalency of hydrogen. During the formation of hydrogen molecule, each atom shares one electron with the other to form covalent bond. So, the covalency or valency of hydrogen is 1. Covalency of oxygen. The atomic number of oxygen is 8. The electronic configuration is 2, 6. During the formation of oxygen molecule, each oxygen atom shares 2 electrons forming double covalent bond. Since 2 electrons are shared by each atom, the covalency or valency of oxygen is 2. Covalency in methane. In the case of methane, there is 1 carbon and 4 hydrogen atoms. Carbon atom shares its 4 electrons with 4 hydrogen atoms. So, the valency of carbon is 4. Each hydrogen shares 1 electron with the carbon atom. So, the valency of hydrogen is 1.